In today's session, we are discussing about various standards of measurements and its classification. The standards of measurements are generally classified into material standard and wavelength standard, and the material standard is further classified into line standard and end standard. We have got two important line standards. One is yard, otherwise imperial standard yard. Second one is meter or international standard meter. 1 yard is equal to 36 inches or 3 feet, and it is maintained by the distance between the two central transverse lines on the gold plugs when the temperature of the bronze bar is constant at 62 Fahrenheit. And this bar is supported on rollers in a specified manner to prevent fluctuation. So preserving the line standard is very difficult. So this is maintained at one place, and replica is made and it is distributed to other regional offices, and from where it is again given, a replica has been taken and it is given to the manufacturers of measuring instruments. The pictures of such bronze bars are shown in this slide, and this one was maintained at the United States, and this one was another type of yard standard which was maintained at London. For meter standard, instead of bronze bar, there it was used an X cross section called Tresca section was used to minimize the torsional strain, because this is lengthier compared to the yard standard. And this Tresca section is actually made of a material that is platinum iridium alloy, platinum of 90% with 90% platinum and 10% iridium. Another standard to consider is end standard. So in line standard, we were discussed about the distance between two engraved lines, but in end standard, it is actually the distance between two parallel faces or parallel surfaces. That is the end standard, and the examples of end standard is one is slip gauge, another one is gap gauge. Slip gauge is another is known as gauge block. Okay, gauge block. So gauge block, gap gauges, ends of micrometer, anvils, etc. are the examples of end standard. The picture shows the examples of end standard, and this is the gauge block. So the gauge block is nothing but a steel block, okay, with having two finished faces, two finished parallel faces. So the distance between that is engraved over here, it is 70. That means the distance between this one face and the other face is 70 mm. Here it is 50 mm, so this distance is 50 mm, and so on. So that is the end standard. It is used. There's an example of end standard, which is the gauge block. Another one is micrometer. So micrometer, here we are actually placing the workpiece for measurement. We are placing the workpiece over here between the anvil and the spindle. So it will also having two parallel surfaces. Another one is the gap gauge. So this gap gauge, this is the gap. This is a fixed gap, and it is a gauge which is actually not for measuring. It is used for checking the measurement, and this also having two parallel surfaces. So the gap between the surfaces giving the measurement. So far we discussed about the material standards. So material standards, we know that it has to be preserved. It has to be preserved from the atmospheric changes. It has to be preserved from theft. It has to be preserved from damages, etc. but that is very difficult, and it is again maintaining the accuracy is also very difficult. So in order to have a solution to this one, we will nowadays following the wavelength standard. So wavelength standard is not a physical one. Okay, we are actually creating some waves, a particular kind of light waves we are producing, and this much we are counting, or otherwise we are defining a meter into is equal to this much number of wavelengths or number of waves. Okay, so that need not be preserved. And another advantage is that it can be reproduced at any place very easily. So that is the second point, that is reproducible standard of length. The reproduction of this standard is very easy. Then error is only one part in 100 millions. Okay, also the error is also very less. So these are the advantages of wavelength standard over material standard. So by this wavelength standard, we can define the meter as approximately 1.65 million wavelengths of a light emitted by krypton 86 isotope. So only thing is that we have to maintain the material, that is light emitted by the krypton 86 isotope. That isotope only we need to use again and again at any point or any location in the on the earth. We can reproduce this standard. Here we can see that 1 meter is defined equivalent to this much wavelengths of that krypton 86 isotope, and also the yard also can be defined using the same wavelengths, same wavelengths of the same uh, isotope. So any standard can be reproduced at anywhere on the earth. So the main highlight of this session was the various classification of measurement systems and the advantages of wavelength standard over the material standard. Thank you for watching.